The evolution of the concept of mass, from ancient ideas to modern physics. Mass is a fundamental concept in physics that measures the amount of matter present in an object. It is a scalar quantity that describes the magnitude of an object's inertia, which is the tendency of an object to resist changes in its state of motion. The concept of mass has been studied and refined by scientists and philosophers for centuries, with our understanding of mass evolving over time as new discoveries and theories have emerged. The earliest ideas about mass can be traced back to ancient Greek philosophers such as Aristotle, who believed that objects had an inherent heaviness or lightness that determined how they would behave in different situations. This idea of inherent weight persisted for many centuries, with scientists and philosophers debating the nature of weight and the relationship between weight and other physical properties. In the 16th and 17th centuries, the scientific revolution brought about a new era of understanding in physics, and the concept of mass began to take on a more formalized and mathematical character. Galileo Galilei, for example, showed that the acceleration of a falling object is proportional to its mass, and he developed the idea of inertia as a property of matter. Later, Isaac Newton introduced the concept of mass as an inherent property of an object that can be measured and quantified. Newton's laws of motion provide the foundation for our modern understanding of mass. The first law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by a force. The second law states that the acceleration of an object is proportional to the force applied to it and inversely proportional to its mass. The third law states that for every action, there is an equal and opposite reaction. Using these laws, physicists can measure the mass of an object by observing its behavior when acted upon by forces. For example, the mass of an object can be determined by measuring the amount of force required to accelerate it at a given rate. This measurement can then be expressed in units such as kilograms or pounds. The concept of mass has important implications across a wide range of fields, from astronomy and cosmology to chemistry and biology. In astronomy, the mass of celestial objects such as planets and stars is critical for understanding their orbits and interactions with other objects in the universe. In chemistry, mass is used to calculate the amount of substance present in a sample, and in biology, mass is important for understanding the metabolic rates and energy requirements of organisms. In conclusion, mass is a fundamental concept in physics that measures the amount of matter present in an object. Over the centuries, our understanding of mass has evolved from ancient Greek ideas of inherent weight to a more formalized and mathematical concept that can be measured and quantified using the laws of motion. Mass has important implications across a wide range of fields, and our understanding of this concept continues to evolve as new discoveries and theories emerge.